Assalamualaikum and hi to everyone. Welcome back to my channel. You can subscribe, like, and share. So before this, we already discussed about the digital to digital conversions. So in this video, we'll just discuss a little bit an overview about the analog to digital conversions, and then we will proceed with the digital to analog conversion. Okay, analog to digital conversions is referred to the we have analog signal and we want to transform that analog signal into the digital data. Basically, there are two techniques that we can use. The first one is the pulse code modulation or PCM, and another part is delta modulation. In PCM, we have three process that we need to go through. The first one, we need to pulse the process. We name it as sampling process. We get the sample. And then the next step, we need to do quantization based on the sampling that we already get from the pulse process. We retrieve the sampling, and based on the sampling, we will do the quantization. And then the last process is encoding. That is the basic process that involve in order to convert from the analog signal into the digital signal. The next point, we have digital to analog conversion. Digital to analog conversions means we want to change the digital data into the analog signal. Okay, the process of digital to analog is the process of changing one of the characteristic of the analog signal based on the information in the digital data. So in this video, we'll discuss about the digital to analog conversion, the ESK, FSK, and PSK. Okay, and then we have another one which refer to QAM or quadrature amplitude modulation, but that part not included in the discussion. Okay, look at this figure. We have digital to analog, means we have digital data. Okay, we have digital data here. We want to change into the analog signal. So that we need a device that we call as modulator. So we have digital data. It will go through this modulator. It will modulate by change one of the characteristic of the signal, and then transform into the analog signal, and then go to the receiver side. At the receiver side, we have demodulator. This modulator will convert this analog signal into digital data. So that is the basic process of digital to analog conversion. Okay, we have four types of digital to analog conversions. The first one, we have ASK, FSK, PSK, and QAM. In ASK, which change the amplitude. In FSK, we change the frequency. In PSK, we change the pace. In QAM, we change the amplitude and the pace. It's a combination of the ASK and the PSK. Okay, bit rate is the number of bits per second, and baud rate is the number of signal element per second. Baud rate refer to the signal, bit rate refer to number of bit. So in analog transmission of digital data, the baud rate is less or equal to the bit rate. Okay, when we want to calculate the S refer to the baud rate. S is always lesser and equal or equal. Lesser or equal compared to the N, which refer to the bit rate. Okay. Example 1. An analog signal carries 4 bits per signal element. Data element is 4, signal element 1. If 1000 signal elements are sent per second, find the bit rate. So based on this theory part, you can identify the R. So R equal to 1 over 4. Now we have 1000 signal element. Find the bit rate. So we can use the formula S equal to N times 1 over R. Okay, this one is the basic formula. Okay, we just fill up. R equal to 4. Sorry, R equal to 4 because we have 4 bits per one signal. And then S refer to the baud rate, 1000 signal element. Okay, signal element is 1000. And N is unknown. The bit rate is unknown. So you can use this formula. S 1000, N is unknown, times 1 over 4. So N is equal S times R. So 1000 times 4 is equal to 4000 bit per second. So using this formula, you can identify the bit rate, the signal rate, as well as the R values. Okay, the next example. An analog signal has a bit rate of 8000 bit per second. So bit rate is referred to the N value. And then the baud rate of the signal is 1000 baud. So it has 1000 signal element. How many data elements are carried by each signal element? So you need to find R. And how many signal elements do we need? Okay, so based on this example, S equal to 1000, N equal to 8000. Okay, and R and L are unknown. So first, we need to find the value of R and then find the value of L. L is referred to the level. So S1000 equal to 8000 times 1 over R. So you need to find R first. So N divided by S, 8000 divided by 1000 is equal to 8 bits per box. That's mean one signal element have 8 bits or 8 data element. So you already know the R. R equal to log L base 2. So you need to find L. So in order to find L, you can use 2 power of R. So it's equal to 2 power f of 8. So that means we have 256 value of level. Okay. The first one, we have the ASK, amplitude shift keying. So basically we use the binary amplitude shift keying. We have 0 and 1. Okay, when we talk about the binary, we have 0 and 1. So at here, the formula for ASK, R equal to 1, S similar or equivalent with the N. The bandwidth is calculated by 1 plus D times S. So this one is the formula in order to calculate the bandwidth for the ASK technique. One signal element, one data. One signal element, one data. Okay, the next part is how we implement the binary ASK. So we have digital data. We modulate with the carrier signal, and then we get the modulated signal in the analog signal. So we need a modulator. So we will multiply this data with the multiplier, we call as the frequency carrier, and then we generate another signal, or we call as the modulated signal, and send to the receiver. At the receiver side, it will go through the demodulator in order to generate the data in digital. Okay, example here, we have an available bandwidth of 100 kilohertz, which spans from 200 to 300 kilohertz. Okay, what are the carrier frequency and the bit rate if we modulated our data by using ASK? So that's mean in here we want to modulate the data into the signal using the ASK with D equal to 1. And the process of transmission is half duplex. So the data flow is half duplex. Okay, the middle of the bandwidth is located at 250 kilohertz. Okay, because the bandwidth is spanned between 200 to 300 kilohertz. So the middle part is 250 kilohertz. We can use the formula for bandwidth to find the bit rate with D equal to 1 and R equal to 1. Okay, because this one we will use using the ASK. So how to calculate the bandwidth? Bandwidth is equal to 1 plus D times S. Okay, based on this formula. R equal to 1, S equal to N, and bandwidth is 1 plus D times S. So 1 plus D, D is equal to 1 times S. So 1 plus 1 equal to 2 times with N. S and N is similar. So we have here N. Okay, we have N. And then 1 over R. So 2 times N equal to 100 kilohertz. So we need to find N. Okay, this one become 1 over 1 because R equal to 1 based on the ASK formula. So you will find the N equal to 50 kilobit per second. So N refer to the data rate. Okay, the next example. In data communication, we normally use full duplex link with communication. So that means both can send data in both directions. So we need to divide the bandwidth into two with two carrier frequencies. So the carrier frequency will shown in this figure. This one is two frequency. So the figure shows the position of two carrier frequency and the bandwidth. The available bandwidth for each direction is now 50 kilohertz, which leaves us with the data rate 25 kilobit per second in each direction. So before this, we discussed about the half duplex. So if we use the full duplex, both have the direction. So each of the direction is equal to 25 kilobit per second. This one is 51 for 50 kilobit per second for half duplex. So if we discuss about two duplex or full duplex, means that we need to divide 50 into 2. So we have 25 and 25. Okay, the next part we go for the binary frequency shift keying or frequency shift keying. So binary equal to two data. We have 0 and 1. So in frequency shift keying, we modulate we change the frequency. Okay, this part is using the formula R equal to 1, S equal to N, and bandwidth equal to 1 plus D times S plus 2 dF. So 2dF here is referred to the difference between the frequency carrier. Okay, between first frequency carrier and second frequency carrier. So this one is 1 plus ds, 1 plus ds. Okay, example here. Let's say we have an available bandwidth of 100 kilohertz, which span from the 200 and 300 kilohertz. What should be the carrier frequency and the bit rate if we modulated our data using FSK? So D equal to 1. So this issue is using based on the previous issues, but the modulating technique is different. Before this we use ASK, now we use FSK. So the midpoint of the bandwidth is at 250 kilohertz. We choose 2 delta F to be 50 kilohertz, which mean, based on this formula, bandwidth 1 plus D times S plus 2 difference frequency. Okay. This is the formula. So bandwidth equal to 100 kilohertz. So 2S, 1 plus 1 equal to 2, 2S equal to 50 kilohertz, because we have 2 delta frequency. So 100 divided by 2 is equal to 50 kilohertz. So S equal to 25 kilohertz. So S and N is similar or equivalent based on this formula. S and N is similar. So S equal to 25 kilobaud and N refer to the 25 kilobit per second. Okay, the next one, we try to implement BFSK. The process of implementation, we have digital data here. And then we need modulate the signal in order to multiply with this data, and then it will generate the modulated signal. So we change in terms of the frequency of signal. So we use the voltage control oscillator. Okay, we multiply this data with the another signal, and then we create or produce another modulated signal. Okay, the next part is about the phase shift keying or 2 phase shift keying. So 2 refer to the binary, 1 and 0. So the formula, R equal to 1, S equal to N. Signal rate and the bit rate is similar. And bandwidth 1 plus D times S. Okay, similar as the amplitude shift keying. Okay, the minimum bandwidth required for PSK transmission is the same as the ASK. So PSK and ASK is similar. Okay. Means the numbers of the total of the bandwidth. But in PSK, the bit rate using the same bandwidth can be 2 or more times greater than the ASK. Okay, this one is the similar part. This one is the difference between both technique. Okay, how we implement it? Okay, we use the oscillator. Okay, phase shift keyings mean we change the phase. Okay, let's say we have the data here. This is our data in digital data, and then we use the oscillator in order to create the frequency carrier. So we will modulate or multiply with this data and this signal, and then we generate another modulated signal. Okay, if you can identify here, the amplitude is change. Okay, the amplitude is change because we apply the phase shift keying. Okay, the next part here is the quadrature phase shift keying. So in quadrature, we have 4 bits. Before this, we use binary, so we only have 2 bit. Okay, this one we have 4 bit. Okay, 0, 0, 1, 0, 0. So basically, the process is we have the digital signal, the digital data. We multiply with the signal frequency carrier, and then we generate another modulated signal. Okay, for Q or quadrature, so we have 2 and then multiply, and then we add. So it's become one signal, modulated signal. Okay, example here. Find the bandwidth for signal transmitting at 12 megabit per second for QPSK. Okay, the value of D is equal to 0. So for QPSK, 2 bit is carried by one signal element. So this means that R equal to 2. Before this, in binary PSK, we have R equal to 1. So in quadrature phase shift keying, we have R equal to 2. So the signal rate or the baud rate is S equal to N times 1 over R equal to 6 megabaud. So if the value of D is equal to 0, we have B equal to S. So it's equal to 6 megahertz. Okay, this one is the bandwidth transmitted. Okay, the next one is the constellation diagram. So this is the constellation diagram. Okay, we have Y as the quadrature carrier and we have X as the phase carrier. So phase is referred to the angle of the signal. So this constellation diagram help us in order to define the amplitude and the phase of the signal element. Okay, when using two carriers, one in phase and one quadrature. Okay, a signal element is represented as a dot, this one dot as the signal element, and the bit or the combination of bits is carry if often written the next to it. Okay, this one is referred to the signal element. Okay, this figure show you the constellation diagram. We have three different of constellation diagram. The first one is the ASK, amplitude shift keying, or OK refer to on and off keying. So one in phase carrier, one signal element, two amplitude 0 and 1. So for BPSK, binary phase shift keying. Okay, the difference at the phase we have start at here and here. One in phase carrier, two signal element. Okay, if we use the polar NRZ, so 1 volt in the phase and 1 volt in the 180 degree phase. So the position of the started signal relative to the 0. And then the next part is the constellation diagram for the QPSK. So we have two carriers in phase and the quadrature, four signal element. Okay, 1, 2, 3, and 4. Four signal element. 1 volt and 45 degrees phase. 1 volt and 135 degree phase. And 1 volt for the negative 45 degree phase. And 1 volt for the negative 135 degree phase. So the degree of the position relative to the 0. So that's how we represent the ASK, BPSK, and QPSK in the constellation diagram. So this constellation diagram help you to define the amplitude and the phase of the signal. Okay, another conversion is analog to analog. So analog and to analog we have AM, PM, and FM. We change the characteristic, okay, the characteristic or either amplitude, frequency, and phase. So we need to use the analog to analog conversion if the medium of transmission that we have only is band pass medium. Only band pass medium that available in order for transmission, then we need analog to analog conversion. Otherwise, we can choose another conversion technique. So that's all for this chapter encoding process or data encoding. We already learned about digital to digital, and then an overview about digital to analog, analog to digital, and analog to analog. So you should know what is the differences between data element and signal element. The digital to digital encoding scheme we have learned is an RZ, an RZL, and the Manchester. If you are given a bit of stream of data in digital, you should know how to represent it or draw the signal in the based on the NRZ, NRZL, and the Manchester scheme. And then you should know how to calculate the signal rate and the bit rate based on the formula. Okay, S equal to N1 over R. The next one, you should also able to identify the scheme or the technique that we use in order to transform the digital data into the analog signal. We have learned about the ASK, FSK, and PSK. Another one is QSK, which QSK is the combination of the ASK and PSK. And then understand the constellation diagram that help you to identify the amplitude and the phase data. So that's all for data encoding. Thank you for watching this video, and assalamualaikum.